Welcome, everyone. I'm Dario Pasino, assistant professor here at the Department of Management Engineering, and I'll be the chairperson for you for this defense today. So first of all, let me welcome the committee of the Ph.D. defense. I have Professor Kevin Collinane from the University of Gothenburg, and Professor Lauri Ojala from Turku School of Economics. And the chair of the committee is Jeppe Rik from the Technical University of Denmark. Then let me welcome the candidate, George Panagakos, and the supervisors. The main supervisor, Professor Herlaus Seraftis, and the co-supervisor, Professor Alan Larsen. So what's going to happen today is that George is going to start by giving up a lecture of approximately 35 minutes. Then we'll have a short break of 5 minutes. During those 5 minutes, those of you who do not want to stay during the lecture, please, during the questions, please leave. If you do stay, please stay for the entire period of the defense and do not leave again. And of course, I forgot to welcome you all. And that would include the whole audience physically here and the one virtually over on the net, because this event is actually being streamed right now. And with that, I would like to give the floor to George on his lecture on green corridors in freight logistics. And this is a work that has been carried on at the Department of Management Engineering under the program of Construction, Production, Civil Engineering, and Transport. The floor is yours.
Thank you, Dario. Can everybody listen to me, actually, because we never test this microphone? Is it okay? A bit higher. I see. Okay. Well, I have to speak up. All right. Okay. Thank you, Dario. Actually, I was thinking that the person who have appointed an Italian to make sure that a Greek follows the rules must have a good sense of humor. So I see a lot of people in this room this Friday afternoon. That means that the green corridors must be a hot subject. Thank you for coming, and also for those who are watching us online. I will try to make your attendance worthwhile. So, these are the topics that I will cover in the next 45 minutes. After a short introduction, I will define the green corridor concept and then concentrate on these three major topics where this PhD project has contributed: the assessment of the corridor performance, the classification of CO2 emission reduction measures as have been proposed in the shipping industry, and what would be the implications of designating the Mediterranean Sea as a SECA area. And I will close with some words on future work. So, introduction. It all began in January 2010 when I started working for SuperGreen, an EU project that aimed at supporting the Commission on green corridor issues. The part of the project that relates to this presentation is the benchmarking of green corridors through the use of key performance indicators, KPIs, where me, together with some colleagues, laid down the groundwork for the methodology that will be presented later on under the management of Harilaos. A few months after SuperGreen was over, I started in NTUA in Athens my PhD project on the same topic under the supervision of Harilaos, sponsored by Lloyd's Register Foundation through Center of Excellence projects at NTUA. And then in August 2014, I continued this work here at DTU on a 2-year contract under the supervision of Harilaos and Alan Larser as co-supervisor. This work has been financially supported by a startup president fund that DTU has granted Harillos, plus an internal grant for this project, and also assisted by 3 Interreg projects, GreCOR, Tentacle, and Scandria to Act. The thesis that I have submitted is based on 3 book chapters and 3 papers. These 3 chapters are all edited, sorry for that, are all published in this book that you see there, named Green Transportation Logistics, The Quest for Win-Win Solutions, edited by Harillos and published by Springer earlier this year. The 3 papers correspond to the 3 topics that I mentioned in the outline. The one on Mediterranean SECA has been already published in Transportation Research Part D. The one on corridor performance assessment has been submitted to the European Journal of Transport Infrastructure Research and is currently under revision. And the one on taxonomy of CO2 emission reduction measures have been submitted to Maritime Policy and Management is currently under review. My work on the corridor assessment has been rewarded with a 2nd place in the Travisos 2016 Senior Researcher Contest on innovative transport ideas in the field of cross-modality. This took place in Warsaw last spring. And I have to tell you that the project also included some other output, 2 other book chapters, 2 conference papers, and the corresponding presentations, 7 other presentations and conferences and workshops, 1 keynote speech at the international workshop, and 1 invited lecture at the University of Sao Paulo. But the material there is already included in the 3 chapters in the book and the 3 papers, so I do not count them again. So let's move on with what is the Green Corridor. In 2007, the European Commission issued its Freight Transport Logistics Action Plan, which introduced this concept. So it is a European concept denoting long-distance freight transport corridors where advanced technology and commodality are used to achieve energy efficiency and reduce environmental impact. Now, in the Brussels jargon, commodality stands for optimal use of all transport modes, either alone or in combination. So if we look into this definition more carefully, we identify these elements here: concentration of freight traffic, commodality and advanced technology, adequate transshipment facilities, green propulsion, that is alternative fuels, the ability to demonstrate innovative transport units, both hardware and software, and of course fair and non-discriminatory access to all corridor facilities for all users. Now, Sweden happens to be the member state that is more advanced in this concept. And the Swedish Transport Administration has worked out a more detailed definition which makes explicit reference to sustainable logistic solutions and integrated logistic concepts, which are hidden in between the lines in this EU definition. And the Swedes have also added one more dimension, a harmonized system of rules. Okay, but why do we need these corridors? Basically because we want to shift cargoes away from the congested European roads. And how we can do that? By improving the competitiveness of rail and waterborne transport. So we consolidate cargoes along certain corridors in order to create the volumes that are necessary to fill up trains and ships. That's the basic idea. Now, these economies of scale also have additional benefits, like that they permit the establishment of a network of refueling and recharging stations along this corridor, and so they can break this chicken and egg situation. We don't have enough clean vehicles because we don't have refueling stations. We don't have refueling stations, we don't have great demand. The other benefit of green corridors has to do with the interoperability problems that we are forced to face in order to secure a smooth operation along these corridors. These problems are really severe in this continent, particularly when it comes to rail, when we have to change locomotives every time we cross borders, or in some cases you have to change the whole trains, actually. And this is only achieved through enhanced cooperation among all the stakeholders that are being involved in a corridor. Now, last but not least, the optimal use of vehicles basically expands the capacity of the existing infrastructure. And that reduces the need for new infrastructure, which not only costs money, but also is not very welcome usually by the surrounding residents. So here is an example of a green corridor. It's called East-West Transport Corridor, and it connects Asia to the west through Lithuania, Sweden, and Denmark. This is a bottom-up initiative, and there are many like that in this part of the world. Bottom-up means that the stakeholders themselves get together and decide that let's do something about this because it is in our common interest. Now, there are also top-down initiatives in this direction, like the one introduced in 2010 by the Commission on rail freight corridors, which aimed at providing sufficient priority to freight trains. Now, the problem with freight trains is that they share the same infrastructure with passenger trains. And you can imagine that passenger trains have a higher priority. That ends so that the freight trains end up with very, very low average speeds. Now, in order to deal with this problem, the Commission created these 9 corridors, the so-called rail freight corridors, where somehow improved priority is offered to international freight trains. But the real boost to the corridor approach was given in 2013 when the EU launched a major overhaul of its TEN-T policy. TEN-T stands for Trans-European Transport Network, and is the basic policy on transport infrastructure. So they introduced this dual layer approach for network design, which consists now of a comprehensive network that is the summation of basically the national modal plans, and this network has to be in place by 2050, while a core network is superimposed on that, which consists of the most important parts of the network and focuses on components with the highest European added value, like cross-border missing links, bottlenecks, and multimodal nodes. Now, the core network has to be in place by 2030, and there are significant funds earmarked for its implementation. Now, the Commission, together with this dual layer approach, also introduced the concept of core network corridors as an instrument for the coordinated implementation of these corridors that can be very long, as you can see, spanning several European countries. And actually, the EU has appointed an EU coordinator for each one of them, who coordinates the various stakeholders that are involved in the infrastructure building and also the operation of these facilities. Now, the question is, are these corridors green? In order to answer this question, we have to understand what are these characteristics that make an efficient corridor green. So by looking at the literature, we have identified these characteristics: reliance on commodality, that means adequate transshipment facilities and integrated logistic concepts; reliance on advanced technology through energy efficiency and use of alternative clean fuels; ability to develop and demonstrate innovative solutions; and collaborative business models in order to be able to have integrated logistic concepts. Now, if you look carefully at the regulations that introduce the 10T core network corridors, you find out that all these elements are more or less there. So basically, in 2013, the Commission has established a network of green corridors as far as the freight dimension is concerned, because the 10T core network corridors also involve passenger traffic and also involve aviation, which is outside the scope of this work. So now we have the rationale for the work, because now we have a network of green corridors and we need to monitor their performance. Sorry. All right, and this brings us to this assessment part. In SuperGreen, we had identified these 6 KPIs. Relative transport cost to the user, that is the transport price, of course. Transport time or speed, depending on the application. Reliability in terms of timely delivery, frequency of service, CO2 emissions, SOx emissions. If you look at this list, you'll find economic efficiency there, you find the quality of transport there, you'll find environmental attributes. But society is missing. And that is because this is the result of a very long dialogue we had with stakeholders. And the stakeholders insisted that we should have a very concise set of indicators in order to make it operable. So at the end, when they had to vote for these KPIs, we end up without any social indicators. But we should keep in mind, but at the end of the day, what is important in selecting KPIs is the objectives that the corridor management decides to pursue. And this can be different from corridor to corridor. Okay, now in terms of methodology, SuperGreen proposed these 4+1 steps. First, we disaggregate the corridor into transport chains. Then, on the basis of a transport market study, we select a sample of typical chains. And these transport market studies are prescribed both for the 10T core network corridors and for the rail freight corridors. And they describe the infrastructure, they identify the bottlenecks, they provide information on traffic flows, vehicles used, and other operational characteristics. So once we have the sample, then we estimate KPI values for each of these sample chains. And then we aggregate back these chain-level indicators into corridor-level KPIs using weights that are also calculated through information found in the transport market studies. Now, the 5th step of this methodology says that this process should be repeated on predetermined time intervals. It's the basic idea behind the CPI, the Consumer Price Index, that the statistical bureaus around the world use to calculate this. They work on a basket of goods and services. And now we create a basket of transport chains that we follow year after year. This is the idea. So 2 years ago, we were asked to apply this methodology on the network that you see here around the North Sea, consisting of road, rail, and maritime connections. So we looked for the transport market studies. There are 3 core network corridors and rail freight corridors touching upon this network. And we found out that the transport market studies were not there yet. And after a few months, when they were published, we found out that they did not contain the information we needed at the level that we wanted for the intended use. So we had to think of something different. And what we came up with was the substitution of these transport market studies with results from a traffic model. And we decided to use the Danish national traffic model in order to construct the sample and also to calculate the weights that we need for the aggregation. The version of the model that we used was calibrated in 2010 It divides the world in 351 zones, covers 23 commodities, 3 modes, railroad and maritime, 17 vehicle types, 25 types of transport chains, which consist of 1, 2, or 3 legs. Here you see, as an example, a 3-leg chain where the first and the third legs are always performed by trucks, and the main haul here can be anything. During 2010, we had almost 3 million entries in the database, and that means 3 million chains. The first thing we did was to define the catchment area, and which you can see it in this slide, but as you can see, the UK part and the Norwegian parts are missing. And that is because when we decided to use the Danish model, it became evident that the traffic that we had for the UK and the Norwegian was too thin to be statistically significant. So we decided to drop these areas out and limit ourselves to the initial alignment of the GreCOR corridor stretching from Oslo to the Belgian and Dutch ports. The next thing we did was to impose some boundaries on the analysis in order to reduce the size of this database. So the first thing was to drop all chains with an annual tonnage of less than 1 ton. Secondly, we dropped all domestic chains because the green corridors are international by nature. And thirdly, we decided to concentrate on what we call pure corridor chains, those that originate and end inside the corridor catchment area. In that way, we reduced the database from 2.9 million entries down to 37,000. Now, this is how the sample structure looks like. The corridor is divided into commodity groups, 13 of them, and each of them is divided into groups by chain type, and then at the lowest level, we have the individual chains. The whole sample consists of 156 chains. Now, the criteria that we used for deciding how many chains of each flow we'll include in the sample are those that you can see here. It's how important is the flow, how homogeneous is the cargo that is being used, how sensitive is the flow to a number of external influences, because the more sensitive it is, the more chains we need to include in the sample in order to capture these sensitivities. And also, we need to have stable and adequately defined chains because we are going to use these chains every year in the future. So as an example, I show you here how we ended up from the more than 1,000 chains of commodity group 22 fertilizers into the 12 chains of the sample. Basically, we said, okay, let's have 1 chain per 100, more or less. So for this chain type here, with 100 chains, we included 1 chain in the sample, 1 for this thing here, and then 4 for each one of these. But if you see the description of the chains, you see that all these 10 are road chains, basically. These 2 are 1 leg, and these 8 are 3-legged road chains. So that was left. So we were left without rail and shipping representation in the sample. So we added 1 and 1 to have a better coverage. So the question then is how we select this one out of this 100, and this is done here using criteria of the vehicle types that were employed and among them which chain exhibited the highest volume. So we ended up with these 156 chains, and here you see the 12 for the fertilizers. Now the next step was to go out and collect information for these 156 chains to be able to calculate KPIs. We started doing that by contacting business associations. We sent out questionnaires without much success, I should admit. The only one that responded positively was the Danish Ship Owners Association, and I take the opportunity to thank Peter Olsen, who is here, for his assistance in that. And we are still working together now to identify those members of theirs that are suitable to provide this information for the chains. Meanwhile, we said, okay, let's try the default values of LTM to see how these results look like. And this is what we've got. First, you see that now the KPIs have been reduced from 6 to 4, and that is because we weren't able to find anything on the reliability and the frequency of the services. So we dropped them out, and the indices that we got are here. You see that rail actually is a safe recommendation for advancing sustainability, as it exhibits lower than average cost, higher than average speed, lower than average emissions. Shipping is the least costly means, but and also the least CO2 emitter, but this cost at a very slow speed, 50% of the average. On the contrary, Ro-Ro shipping exhibits a totally different figure. We see here above average cost, very high speed, and extremely high emissions. So all in all, the methodology can work, provided that we are able to get information from the stakeholders to calculate the KPIs. And we have proposed some ideas to reduce the size of the sample to make it more manageable. Before changing subject, I want to emphasize that this methodology is suitable for monitoring the performance of a single corridor over time, but it's not suitable for comparing different corridors to each other. And that is because it doesn't take into consideration the specific characteristics of each corridor. And crossing the Baltic Sea requires different solutions than crossing the Alps. So we cannot compare apples with pears. Okay, so classification of CO2 emission reduction measures. We did a literature search, and we ended up with a framework that is closely related to what is called decomposition analysis. Now, this term was introduced by a Japanese researcher called Kaya back in 1990. And he used an identity like this to express CO2 emissions. So these are basically a product now of 4 factors. The first factor is CO2 per energy consumed, and that is the carbon intensity of the energy mix that we use. The second is the energy intensity of the economy, is how many units of energy we need for an extra $1 of GDP. Then is the GDP per capita and the population. Now, thinking along these lines, we came up with this identity, where we express CO2 as a product of 6 terms. CO2 per energy, this is megajoule, is the units that we use to measure energy. So is the carbon intensity of the fuel, and then this is the energy efficiency of the vessels that we use, energy per vehicle kilometer traveled. And then here we have the capacity of the vessel, the utilization rate of this capacity, the tons lifted, and the average distance of the hull. And of course, we sum over fuel and vessels. Now, we don't have time to go through all different measures that have been proposed for shipping, but I will just go through the titles. Here we have alternative fuels. Here we have energy efficiency, and there are a long list of technological upgrades that we can employ, plus operational practices like slow steaming, weather routing, MRV, things like that. Here, when we talk about capacity and use of the vessels, I deliberately put them in the same box because I want to mention an excellent article by Kevin that we have here. this thing here, the capacity, goes up together with the utilization rate. It makes no sense to have larger vessels if they sail empty. And in order to improve the utilization, you get involved into these alliances that we see in the liner shipping business. And then, of course, we have to manage transport demand and lower the average distances through restructuring of the global supply chains. And in addition, we have measures that target a combination of factors, like the optimization of transport operations that many of you in this room work with. And also a family of measures is this, what's called market-based measures, which can target either the vehicle kilometers or the energy consumed or the emissions themselves, like the ETS, the emission trading system of Europe. And of course, we can play with shifting vessel companies and modes. So to conclude, there is a wide range of measures for reducing CO2 in shipping, but sustainable mobility is a very complex issue, and it requires packages of complementary instruments rather than single policies. We should always keep in mind when we try to intervene with policies that there are these substitution and income effects that sometimes are really annoying. And then when we are looking for win-win solutions, we have to remember that economy and environment are not always conflicting. Here, all the measures that target one of these factors, either alone or in combination, end up with lower energy consumption. And energy consumption costs money. So every time we employ one of these measures, not only we economize on funds, but we also save CO2 emissions. And finally, one thing that we should also remember is that shipping is not alone. In this world is only part of a supply chain, and we should look for how to optimize the whole supply chain in terms of emissions. Now, very briefly on the Mediterranean SECA. Here you see how the various types of vessels, of ships, compare with other modes of transport in relation to CO2 per ton kilometer. And that is about as long as CO2 is concerned. But look what happens when we turn into SOx, the sulfur oxides. Here are the trucks, here are the trains, and here are the vessels. Now, in order to cope with this problem, the International Maritime Organization came up with restrictions in the sulfur content of marine fuels. These restrictions are very severe for specific sensitive areas that are called SECAs. And here you see these SECAs is the Baltic Sea, the North Sea, and the east and west coasts of the States. So what will happen if Mediterranean also becomes a SECA? In order to answer this question, we compared two alternative routes that cargoes originating in Thessaloniki, Greece, and ending in Berlin take. One route is a road only that you see here, and the other is a combined transport that you see there, which includes a ro-ro crossing here of the Adriatic, and then a track on rail service across the Alps. Now, I will not bother you with the mathematics behind it. We have used a binomial logic model to do that, but I will describe it only with this curve. The x-axis here is the changes in the freight rate of route 2. That means that if nothing changes in the cost of route 2, then the share of route 1 will be as is today, which is about 68%. But if for any reason the freight rates in route 2 goes up, then cargoes will shift from route 2 to route 1, and the share of route 1 will go up. This is what this curve says, basically. Now, once we have calibrated this curve, then we can use it to make predictions. And we have used it to see what happens when the Mediterranean becomes a SECA. Supposing that the ship operators will choose to shift the fuels from the heavy fuel oil that we're using today to the marine gas oil, which meets the regulations, but it is much more expensive than the first one. So, and this is the ship that is used one of the ships that is used for this trade. And by doing all our calculations, we found out that this will result in a modal shift of 5.2%. So 5.2% of the cargoes will shift from route 2, the combined transport, to route 1, which is the road only. And actually, if we play with some of these assumptions, this number can go up to 17%. So, in terms of emissions, we see here that route 1, the road only, is performing better than route 2, and that is because, sorry for that. And that is because route 2 is longer than route 1 by 28%, because route 2 involves this sea leg where the ro-ro vessels consume a lot of fuel because of speed, basically, and because of the double loading factor. And another reason is that the train leg that performs quite well in route 2 is too short to make a difference. So the designation of the Mediterranean as a SECA will result in better environmental performance for all emissions. And that is because 5.2% of route 2 will go into route 1, which is environmentally performing better, and while the rest of route 2 that remains there becomes cleaner due to the new fuel. So should we designate the Mediterranean as a SECA? We have positive indications, but we cannot say for sure because this is only a case study. Okay, so the last 5 minutes, I'll spend talking about future actions. Our work on corridor governance is already providing input to the Untitled project, while in the framework of Scandria to Act project, we will apply the same methodology that we used in Mediterranean to check the performance of ro-ro services along the Scandinavian Mediterranean core network corridor. And plus, we will develop this methodology to include financial performance and the viability of the existing services. Now, in terms of the corridor assessment, we have to finalize discussions with the business associations, circulate the questionnaire to the selected members, follow up on that, and then collect the responses and refine the sample based on those, calculate KPI values, and disseminate results. Now, in terms of this dissemination, this brings us to this slide here. While working on this, I discovered that cost and quality data in the official Danish transport statistics are completely absent. The other problem is that Denmark scores quite poorly in terms of LPI, the Logistics Performance Index that the World Bank is using, which is the child of this gentleman here, Lauri Ayala. Yes? So, this is the situation in 2016. In terms of the LPI score, the composite index, Denmark ranks number 17. Germany ranks number 1. Sweden ranks number 3. Netherlands ranks number 4. Denmark is only better to Norway, which ranks number 22. And this index here basically consists of 6 components, one on customs clearance, one on condition of infrastructure. This is the easiness in arranging competitively priced international shipments, competence in logistics, cargo tracking and tracing, and reliability. If you see how Denmark performs in relation to these other countries on all these components, you see that we are not doing that good. And I don't think that we should accept that. We need to do something about it. Now, what is this something that we need to do? The first thing we can do is raising awareness. And I borrow this slide from Kathy Macaris, which gave this presentation 3 weeks ago. She talked about the 4 A's of sustainable transport, and the first of these 4 is awareness raising. And how can we raise awareness? There are different approaches. The US has decided to publish a special volume of statistics called Freight Facts and Figures. And I have selected a number of titles here to get an idea. Producer pricing, that is producer, that is transport service producer. So we're talking about transport prices here as an index, of course. Where is it? Average track speeds, performance measurements of corridors, congestion, trip reliability, fatalities, energy intensities, greenhouse gas emissions. Other countries like France, Canada, South Africa have decided to go with logistics observatories, which collect and disseminate data, produce analysis, build dialogue between public and private stakeholders, and raise awareness. Only in France one can find 4 such observatories. And the Dutch have gone a step further. They have established an Institute for Advanced Logistics that takes care of training and collaboration projects between private and public sector. And this is not only for Denmark. The same thing can be applied in developing countries. I'm sorry for the quality of this picture, but I only get this journal in hard copy. But this is a good news. For last year, 2015, the global CO2 emissions dropped. And it is the first time that these emissions drop while the economy grows. You see here that EU is performing well. Now it's becoming a trend for some years that EU drops its emissions. The US have stabilized their emissions. Even China managed to drop their emissions last year. But look what happens with India. And it's not only India. Our Harvard colleagues here provide a forecast of the annual growth rates of CO2 emissions through 2024. You see what happens in all these developing countries. Annual growth rates. Yes. So now I think that the interest should slowly focus on developing countries, and this can be important for our UDP colleagues who work with UNEP, because MRV, monitoring, reporting, and verification of CO2 emissions, is regarded as a nuisance from developing countries. We are aware of it. But if we combine these measurements with other things that are really interested in, like customs clearance and prices and speeds, then we might end up with something useful. So thank you for your attention, and I'm looking forward to your questions.